Welcome to this class. Welcome to this class. We're looking
Thank
at
you.
questions on rationalization, complex numbers, and irrational numbers. So let us look at these questions. So um, we already answered the other questions in other videos. So we are doing this part from 3. We're doing 3A, and 3B. So we do 3A and 3B. Okay, we also touch the modulus part. Yeah, I forgot to mention that we also do modulus part. So the question is evaluate. The question is evaluate modulus. Sure, you can see that modulus. Then there's another modulus that follows. It closes minus modulus 3. Then it closes like that. Board. So how we do this question? Do this question in the following manner. So it says modulus of, then there's a modulus inside first that opens -2, then modulus minus modulus 3. Dealing with questions on modulus, anything that is in the modulus like this, if it's whether it's negative or positive, it will always give out a what? A positive. Then it's in the modulus, it will always give you a positive value. If you have a 1 here, you still get a 1 in the what, in the end, like that. We have modulus of 2 here, -2. So that's going to give us +2. So that will give us 2. Then we have the minus sign in between. It comes there. Then we have -3 there, modulus. So that will give us from here, we have that negative. We have that 2 minus 3 gives us -1. And this is just going to give us in there. Then the following question that follows, say, has or is in that manner where we have the big modulus 3 minus 9 closed over 3. Then we have minus, there's a commodulus 2. Okay, like that. So how are we going to do this question? So I'll move to my board again, and I will erase this just to make more space. Okay, so question is this. I have a bigger one. Then there's 3 here minus, there's 9 like that. Okay, then I have modulus, there's 3, then minus, then I have -2 here. So from here we can move that on top what we have. So on top we have, so let's keep the bigger modulus, it still be there. Then I'll have, so what I'll have is okay, just erase this. -3. When I evaluate that, I get +3. So it will be 3. Then I have a minus sign in between. So minus, like that. So then over, I have 3 here, which is seated in a modulus. So if you can see there's this modulus, it goes up to there. So that's gonna come like that. So that will be minus. Then this -2 will give me +2. Then that's still in the modulus, and the bigger one goes there. Then I have that here, -6. Then over here, 3 minus 2, I get 1. So I get 1 like that. Then -6, so 1 is to be 1. 1 divided by 1 will still give me negative. Oh, I mean 1 divided into -6. I get -6 there. Then I have modulus of -6. This will be equal to +6. So that is how I evaluate that question. Okay, let's go on and look at the next question. So the next question, we're dealing with complex numbers. So it has this. Write the complex number. So we have this complex number here, which a plus ib. Should write it in the form a plus ib. So how do we look at complex numbers? So when we're dealing with complex numbers, we have the symbol, or the symbol I, which is what? Which is introduced. The symbol I. So now, this symbol I, how do we handle that? So we have that uh, I is equal to the root of -1, and I squared is equal to -1. So when you're dealing with complex numbers, things that you must know that will help you to solve the question. So now let us solve this question. So the question is I is 2i cubed minus 3i to the power 4 plus 2i. So that's ib, like that. So how are we going to write in the form like as the real part of this complex number and b as the, how we will do this is we have to at least make this where we can replace I squared with -1. So where there's 2 here, I can rewrite this in the form where I have I multiplying by I squared. I do, when I multiply I and I squared, I can just add the powers, then I get this I cubed. Then minus 3, so I can do the same here. So I can say I squared, then I can put a squared there. So this is the same because this by 2 times 2 here, I'll get what? The power 4 there. So I'll get that. Just keep that, then plus 2i. So now I can replace where there's I squared with -1. So 2i -1 minus here 3, then I have 5 -1 plus 2i. Okay, so now here I just multiply. So negative, so 2, 2 -2 I. Then I have I squared. Negative I squared gives me positive. Since I'm squaring, so it will be positive, +1. So +1 multiplied by -3, I'll just get -1 multiplied by 5, I get -5 plus 2i. So here, what am I going to do? So I see that this part and this part, they what? They cancel out. They cancel out. When I add this plus that, I'll get -8 in this case. So this is my answer. Now they've said I should write it in that form. I do not have an imaginary part, but I can write that in the form to say -I plus, so I have I, then my imaginary part is what? Is 0, like that. So this is how I write that question. That's how I can write this question. Okay. Are there any questions here?
No, there aren't. I feel like this is the first time I've come across the simplest way of breaking this down.
Okay. All right.
Yeah,
So
thank you.
let's do the question that follows. So the question that follows says, write the complex. So it says, write the complex number, this complex number in the form a plus I, b. So in the same form which we were being told, that's how we should write this. So how are we going to do that question? So if you can see in this one, we are dividing. In this one, we are dividing. So it's very important to remember the rules when it comes to these complex, when it comes to complex numbers. So how we do that, we have this question, 2 minus 4i, okay, divided by 3 plus 5i. So to get it in the form I know to get rid of the complex number in the bottom, I have to multiply by the conjugate. So what you do here is you multiply by the conjugate, both in the numerator and in the denominator. So the conjugate of the denominator here, so what will change is the positive sign there, it just becomes negative. So you multiply I, and there in the top 3 minus 5i, like that. So how do we work out there? 2 minus, so what you do, okay, so 2, they are having 2. So 2 multiply 3 minus 5i, like that. Then the other part is minus 5i. Okay, divided by. So in here down, you can multiply, or you can remember the rule to say when we have this z. So z is what is used. Z, our complex number in the denominator is 3 plus 5i. Then our conjugate, so conjugate has a bar, is what we are multiplying the other side, which is this. So this squared plus b squared. So you identify your a. So your a is 3 and your b is 5. Then you just square those, plus 5 squared. Okay, so on top, what you get is when you multiply 2 by 3, you get 6. Then minus 10i, then my I plus 20. So plus 20i squared, 20i squared, like that. So what do I get in the bottom? 9 squared is 9 plus 5 squared is 25. 5 squared is 25. So let me erase the two part. Okay, here. Let me erase this. Okay, so how do I then proceed from there? So my so I can group there. So, or let me replace where my I here is. So where there's I squared, I can replace negative 1. So when I replace negative 1, this will multiply it to be negative 20. So it will be negative 20. So I can group 6 minus 20 like that. Then I a negative 12i, then I'll get negative. So I can add those like this. That's what I mean. Then divided by. So when I add in the denominator 9 plus 25, 9 plus 25, I just get 34. So there I'll get 34. Then on top, I can subtract that. 6 minus 20, I get negative 14. Then adding this to negative 10 and negative 12, I get negative 22i. So divided by 34. From here, I can divide the negative 14, 22i divided by 34. So from there, we just have to simplify. We just have to simplify that. So how do we simplify? So we divide. So let's divide by 2. So when divide 2 into negative 14, we get negative 7 into 34. When we divide 2 to 34, I get 17. I get 11 I, then there to be 17. So remember, they told me in the form A plus IB. So which is then the imaginary part. Can write it more clearer in this form. 17 minus, if you want, you can bring your I here at the end, just, or in front. Here's how you find and solve this question. Okay, do I have a question there?
No, it's clear.
Okay, all right, thank you. So let us move on to do another question. So how are we going to do the other questions? Okay, let me wrap this. Uh, okay, not these ones first. Uh, okay, let's start with these ones. Let's do these ones next. So we have these questions that read, simplify the expression, simplify the expression 1 over 1 plus root of I have root of 36 minus 3. Then I have 48 plus 27. 48 plus 27 in that form. In the form P plus Q root of 3, where P and Q are rational numbers. Where P and Q are rational numbers. Okay, here's my question. That's gone. Uh, all right, so still have my question here. Okay, so how we do that is so we have to simplify 1 over 1 plus root of 36 minus 3. Then here I have what do I have here?
48.
48. Okay, so 48 plus 27 there. Okay, so root of 3. So now, meaning where there'll be my roots, I must get 3 there in the simplest form. So how do I do this? So I can see that this one, 36, I know it's a perfect square. So here I'll just get 6. That's where one of them will be root of 3 and the other one will be a perfect square. Then also the same with 27. So I'll write this 1 over. So there, root of 36 will just give me 6. Then I have minus 16 by 3. So 16 is going to give me a perfect what's square. Then the 3 is the one which will remain like that. Plus, then I do the same here. 27, I'll get that. So here I'll have 1 over, I can add this 1 plus 3, I'll get 7. Then I have that, okay, I have the negative 3, then I have root over, so here when you separate them, 16, like that, root of 9, then root over 3, like that. So here, what do I get next? So I'll have that this will be equal to 1 over 7, then negative 3, there will multiply with this gives me 4. 4 root of 3 plus 3 there, root of 3, like that. That's what I get. So from here, I can proceed to just evaluating that. So what I get is 1 over, so that's 7. Then I have negative 3 multiplied by 4. I get negative 12 root of 3. Then I have plus 3 root of 3. Okay, 3 root of 3 there. Then I can just add what's there. I can add. So this gives me 1. So I can add this. So I get 7 of 3. So like that. Now they're telling me I should put it in the form, in this form here. So where these are just rational axis numbers like that. So how do I do that? So for this to, for me
Sorry,
to,
where is the 9 coming from?
okay, so you have this negative 12
Oh, okay,
plus,
I get it.
yes, that's where the 9 is coming
All
from.
right.
So now from here, what do I do in order to get to come to this form? In order to come to that form, I must rationalize, meaning I must multiply by the conjugate there in the numerator and in the denominator and in the numerator. So I have 9 root of 3. So in the top one, I'll just have 7 plus 9 root of 3. Then down there. So when it comes to such, where I'm multiplying the conjugate, just square this, and then square that. Like to be down, I mean. So, because when you multiply the what's there with the conjugate, so when you square that, you have this. When you square 7, you get 49. Then when you square, so minus, you square 9, you get 81. Then here when you square root of 3, you just get 3. So this will multiply like that. Then I have 7 plus 9 root of 3 divided by 49. So I can multiply 81 by 3. 81 by 3, I get, this will be minus 243. Minus 243. So there I can just subtract. Can subtract to get my answer. So I can say that subtract, I get negative 194. So that will be 7 plus 9 root of 3 divided by negative 194. So from here, I can divide 7 here to give me negative, I know, like this. Then I have plus or minus, not plus, but minus 9 194, then I have root of 3. So now from at this stage you check, can I simplify this further? Can I simplify this further? Okay, so 7 cannot divide into 194, so I just leave it like that. Can 9
Um,
divide into,
Question.
yes.
How did the 7 become -7? Sorry.
Okay, so if you can see here, I'm dividing by negative 194, right?
Mm-hmm.
Yes, so that's how it is. So it's just not 7; it's the entire fraction that is. Maybe I've not written it
Okay,
well.
you've
Let me.
multiplied the entire fraction on top of the negative.
Yes, so it's going to be the
Oh,
negative since it's dividing. Even here, that's why we get negative
okay.
9 over 194. So from here, there's nothing that can divide into to both 7 and 194 without leaving a remainder. Same for 9 and 194 plus q root of 3. Since they said this p should be a rational number and this is and q a rational number. And I can see that there both my p here negative 1 negative 7 over 194 minus negative 9 minus 9 over 194 is, they are both rational numbers. So yeah, I've gotten my form and that's how you answer that question.
But to
Okay.
me, I
Any
feel
question?
like the correct. Okay, I'm not saying that this answer is wrong, but I feel like the one that looks better was 7 plus 9 root 3. It's similar to P plus Q root 3.
At 7 plus?
7 plus 9 root
Mm-hmm.
3 is similar to what they wanted, p plus q root 3. So if I didn't know that you have to go further, I would leave it here because it looks correct. So
Okay, so it's not about it looking correct. Let me show you the question. Read so the question says simplify in the form p plus q root of 3, where this p and q are rational numbers. They have to be
okay,
what? Rational
rational
numbers.
numbers. All
And
right.
rational numbers, we say these are numbers that can be expressed in the form a over
Over
b.
b.
Yes, that
Mm,
definition where b is not equal to 0.
mm,
And these two have no common factors. And we can see that's the form where we've
mm.
ended. So there, that's how
All
you
right.
conclude. Ah, okay. Now let's do the question that follows. Question that follows is a more tricky question, a bit tricky, I think, but it's easy. Yeah, so it's saying given A is irrational. Let me just change my like this. Okay. Given that A given that A is rational. So A is rational. So if A is rational, it can be expressed in the form A over B, where B is not equal to 0, and A and B have no common divisors. Then they are telling us root of 2 is irrational. So root of 2 cannot be expressed in this form A over what? Over B. So it's irrational. Then they're saying A is not equal to, so A is not equal to 2. Then they're saying show that this is irrational. Must show that that is irrational. So how do we do that question? Okay, so to answer the question, we answer by contradiction. So you first make an assumption. So assume that the question we've been given. Okay, let me just check the question again. I didn't write it in my worksheet. So the question is a minus 2 over root 2 minus 1. So, okay, so uh, a minus 2 over root 2 minus rational. You assume that it's rational, which means it can be expressed in the form is not equal to 0. So, okay, since there's a in there, let me not use a, let me use p over what? P over q to avoid confusion. So let me use p over q, where q is not equal to 0. And then p and q have no common divisors. So we use proof by contradiction. Yeah, divisors. So if we've a minus 2 over root of 2 minus 1 should be equal to p over what? Q. From here, what do I do next? From here, let me aim on, since I've been told in the question that root of 2 is irrational. So let my aim be just to remain with the root of 2 on this side. Let me remain with root of 2 on the left side. So let me I can cross multiply this. So when I cross multiply, I'll have p is equal to root of 2 minus 1, like that. Q equal to a minus 2. From here, I can divide p both sides. Then I'll have root of 2 minus 1 q, here a minus 2 over, this is over what? P. I'm dividing p there. So from here, what do I do? So what do I do from here? So I can so I have 2 is equal to q, and have a minus 2, this is over p, then to be plus 1, plus 1. So let me erase part of my board. Okay, let me erase the same down part here, or this here. Okay, so from there, I have that I can make this into a single fraction on the uh, right side. So I have root of 2 going to be equal to q, have a minus 2 uh, over p. So I can have a common what's this here. So let me have a common denominator. So p is a common denominator. Let me write this. So I'll say over p is going to be down here. So p into p, it cancels to be 1. Then you have q a minus 2 there. Then into 1, there it's just going to be plus p, like that. Yeah, it's going to give you plus p. Okay. So from here, what do I do next? I can expand what's on top. So I have what's on top. I have q. I have q a, then minus 2 q plus p divided by p, like that. So this is what I have. Okay. Check that. I hope this is okay. Root of 2 plus so A over B Q. Okay, yeah. So that's what I have. So from there, how am I going to conclude? So I've already been told that this here, A is rational. So A is rational in the question. So when I multiply this number, Q, it's because Q is any integer by this A, I'll still get a rational number. And when I subtract, still the same. And I've expressed this here on my right in the form P over Q, because there are no left. I have this root 2, and this is irrational. And I know that an irrational number cannot equal a rational number. So my right side is rational. So if that contradicts, it means that root of 2 cannot equal to this side. So root of 2 cannot equal to the right side. So if it cannot equal to that, for this to be true, for this to hold that root of 2 is irrational, it means that even the right side must be irrational. So if the right side is irrational, then it means that A minus 2 over root over root 2 minus 1 is also irrational. So then this is the end of my proof. All right, so that's how you conclude. So you write that statement to say, since my left side here, root of 2 is irrational, and this right side is rational. So for this to hold that root of 2 is irrational, it means that even the right side must be irrational. So if the right side then is irrational, it means that even this here is going to be irrational. So that's how you solve that question. Okay, any question?
No, not. I don't
Mm.
have any question, but repeat the last statement to see. And an irrational number cannot equal a rational number. Therefore, it contradicts the what?
Okay, yes. So an irrational number cannot equal a rational number. So because they can't be equal, it contradicts this assumption that we've made that this is this part here, this is rational. It contradicts this here has to be irrational. Is that
All
clear?
right, I get it. Yes.
All right. Now let us do, okay, we'll do one last set of questions or two questions. This was from the paper that they wrote. This is 2024 exam. So, okay, these are the questions that are there. So, these will be our last questions for this lesson. Sure, then you'll be vested in rationalization and yes, all those. So you have Z to be equal to -1 plus I. Then they're saying find the value of modulus of Z bar minus I minus 3, then there's like a squared there. How are we going to solve this question? So this question is not hard. Okay, so how we do, we've been given that our complex number is equal to Z -1 plus I. Then we're told to find the value of modulus of bar minus I minus 3 squared. So here, what is going to help us is to understand complex number. That's the modulus. So when you put a complex number in the modulus, it is defined as b squared. So this is the real and imaginary part. Just square them like that. So you have that your z is -1 plus I, meaning your z bar will just have. So there we are going to put the conjugate. So it will be the modulus of -1 minus I. Then you have minus I minus 3 like that. So from here, what am I going to do? So from here, what I do is Z. So Z bar, to make it more clear, you put that complex number that you have like that. Then that is what is going to give you. So that is a squared plus b squared. So from here, let us simplify what's inside. So I can add this -1 and negative this negative I get -2 -2 I. Then there's a squared there. So from here, what do? I just use that same rule. So meaning I'll be squaring. So I'll be squaring -4 squared, then plus negative here outside there. So don't forget the square here. We have this square. So that will be equal to, So what's inside there? You have 4 squared is just 16 plus 2 squared is 4. Then I have that. I get that this will be 20. So it will be 20, then square. So a square will go and my value just be equal to 20. So that's how you find this question. Okay, the last question we're doing is this question express. Okay, it's this question express 5i. So I mean 5 over I plus 2 over I3 minus 20 divided by I to the power 18 in the form A plus IB. So how do we do this question? So have the question 5I plus 2 I power 3 minus to form A plus IB. So remember, this is going to be your key. So 5, how are we going to handle this one here? So that's I squared, then minus 20, I have as I, so that will be I squared, same as I squared, the power 9. Since when I multiply 2 by 9, I get is equal to 2. Then okay, not equal, but uh, that should be plus. Okay, so plus 2. So why there's I squared, I put negative 1. So when I put negative 1, I have I multiply negative 1 there. Then I have minus 20. Then I have negative, uh, negative 1 to the power 9. Negative 1 to the power 9. So what do I get from there? So it will be 5 to be equal to 5. I, then that will be minus. So negative 1 multiplies to be minus. So here to change from positive to minus 2 over I. Then I have this one here. So so negative I to the power 9. Always when there's an odd number here in the in the exponent, know that you're going to get a negative value. So this will just give you negative 1. If there's 1, but this negative 1 will divide with this negative here to get a positive. So that will be plus 20. Okay, these are they're having the same bases, so I can just subtract what's on top and keep the base. So it will be 5 minus 2. I'll get 3 over I. Then I have plus 20, plus 20, like that. So here, have we gotten the form that they're asking for? So you have this where you have 3 over what? I. 3 divided by I. So here you can even, okay, you can make that into a single fraction, please. Okay, so let's make that into a single fraction. So just erase. Okay, here's my eraser. Here, let me erase this top part. So, all right, so I have 20 plus 3 over denominator is I. So there I will get 20i, I times 20 is 20i. Then I into I1 plus multiplied by 1. From here, to get that form, I just have to rationalize, meaning I must multiply by the conjugate. The conjugate of I is just negative I. Conjugate of I is negative I, and there, what do I get? So this negative I in the numerator multiplied by 20i, I'll get negative 20i squared. Then where there's, in here, in the bottom, negative I squared is just, okay, to be negative I squared. There's negative I squared here, I can replace negative 1. So that will be negative 1 multiplied by the negative there to be positive 20. Then I'll have minus 3i. Here to be negative, multiplied by that to be positive. So you do it to be divided by positive 1. Then you get I. This is the final answer. Okay, so this is the end of this lesson and solving those assessment questions.
All right, thank you.
Are there any questions?
Hmm, I don't think so.
Okay.